Morning, everybody. Hope everybody's doing well. My name's Trey Peavy, and I'm the RP product manager here at Colmet. I'm just responsible for the filtration part of our business. Now, I have been at Colmet for many years now and worked through the booths and things like that. So, in our presentation today, we're going to talk about some booth-related items as well as some filter-related items. But let's just kind of run through some of our normal introduction here really quickly before we get going, just in case there's anyone new attending the webinar that isn't familiar. So Colmet is a company located in Rockwall, Texas. We do all of our manufacturing in this one location. That is our sheet metal and our filtration side of our business is all out of this place. We, ask anybody who would like to come by and visit us to let us know. We're proud of our building and what we have for a facility, and be happy to let you guys come around there and see it. So Colmet really breaks down our business in three business segments. Our first business segment is our core and catalog equipment business, which is just where we're taking spray booths and putting them as a standard item. We have another where we have some engineered projects and products, which are a little more technical requirements for these and some forethought. And then we have an RP filtration product. So those are our three product segments. To give you some examples of those, the core and catalog equipment, as I mentioned, are more of a standard type of booth. Now that can be a small booth up to a large booth like a locomotive, but the booth geometry is fairly simple. The airflow is fairly simple. For us as a spray booth manufacturer, it's very run-of-the-mill type equipment, even batch ovens of certain sizes and pass-through powder applications. But once we move out of that sort of that norm and the things that we see, a little more in our day-to-day, we move into our engineered projects, which, handles a lot more, design, a little more engineering up front. The examples you see on your screen, there's a very large booth there for the offshore oil rigs. It's like 265 feet wide, I believe, close to 200 deep and about 65 feet tall. That particular booth blasts, paints, it's humidity controlled. So obviously there's a lot going on with that type of equipment. So that falls in our engineered projects group. And really where we want to focus is on our RP filtration products for my type of presentations, right? So to give you a timeline of that, in 2017, Colmet acquired Research Products, which a lot of people say, Trey, what does RP stand for? And what that is that's just Research Products. We kept the RP initials in the name just to keep some brand recognition. Research Products has been manufacturing, which was the first manufacturer of a slit and expanded paper filter. And has been doing it well over 50 years. So there's a lot of brand recognition out there. So we kept that. And we took over that part of their business in 2017. In 2018, we integrated that into our facility and brought all the manufacturing into our Rockwall, Texas plant. So that was our main focus for those years. Last year and this year, our main focus is growth. And we brought on some filter specialists. We created some new products, some new programs. One of the new programs that we're excited about is our 5-year warranty program. And what that really is if you buy a Colmet spray booth that qualifies for, pretty much a liquid spray where it's not a powder spray where we're utilizing the paint arrestor, then we send out the W series filtration with it. And because we're so confident in that filtration and we're the manufacturer of it and we can know the quality and we know what's happening, that we offer a 5-year warranty on our spray booths. And that includes the booth and the air makeup units. Anything associated with that piece of equipment is purchased from Colmet. So that's a really cool program and exciting, especially if you're tied into the sheet metal or the booth side of our company as well. That helps you move through there some. So just to move through to our overview of our presentation today, this is a continuation of a webinar that we had done previously with exhaust filtration cost savings. And what we really concentrated in that presentation was to show you the advantages of going from a pad filter, which is a 20 by 20 or 20 by 25 cut filter, to a blanket type media and utilizing the filter lock. So I'll recap a little bit of that for this presentation, but mostly we're going to focus on a manometer. And oddly enough, you say, well, I don't understand how that can save me money. Well, from an end user perspective, a correctly set up manometer could possibly extend the life of their filtration, right? So and we'll talk a little bit more through that as we go through our presentation, and then we'll cover some of our incentives that are still running, just to help to stimulate during this time, with the COVID-19 lockdowns and things like that, just to help stimulate hopefully some business for our distributor partners as well as our ultimate end users. So we'll go ahead and get rolling through this presentation. So thanks for bearing with me through that introductory part. But the RP filtration, in case you're not familiar, is a slit and expanded paper. It's the way that it's engineered is really sets it up well to depth load. Compared to like a polyester, which does a lot of the catching on the front of the polyester surface. When you're talking about particulates and particulate sizes, there's larger and there's smaller. Well, those larger ones get caught on the front layer, and they face load that type of material, polyester, fiberglass, things like that. They want to face load. They don't necessarily load from the back to the front or the finer materials out to the larger density opening. So our filter is sort of designed to function that way because of the paper layering and the slit sizes. We do use a polyester backing on some of our models and our legacy series if we're looking to bring our efficiency up for those smaller particulates I was talking about. And they're available in pads, blankets, and in bags. So there's several models to these. I bring this slide up every time because I've had people say, well, we tried paper filters and they didn't work, and I don't want to talk about them anymore. But to be honest with you guys, before Colmet acquired RP Products in 2017, I had the same opinion. I thought there was one paper filter. I didn't know there was different layerings and different paper weights and different orientations and slit sizes and things like that when it comes to the slit expanded paper. So I bring this slide up to show you that we have a lot of just standard families or models of filters, and each one performs differently with a different type of coating. So we more than likely we have a filter that will work for your application. Now, I'm not going to sit here and say that our filter works for 100% of applications. To be honest with you, if any filter company makes that claim, then they're kind of stretching the truth a little bit. Now, will it work? Sure, it will. Is it the most optimal to use in that situation? Probably not. So we have different models so that we can help that optimization to get where we need to be and achieve what we need to achieve. So I bring that up for that. Our newest filter that I talked about with our 5-year warranty is what we call our W series. And in essence, it's almost exactly the same as what we've been manufacturing before, but we did change up the paper layering. We did change up the face sheet of this filter and put a white face sheet on it. It doesn't change the performance of it any, but it does sort of brighten the booth up. It does change the look of the filter, and it gives the ability for this filter to be identified in the field as what it is, and to separate us from maybe our own filter as well as our competitors. So the biggest difference here is our polyester that we use with these filters, and it's a virgin polyester, where we're on our legacy line, we use a recycled polyester. So that is one of the biggest things. That's why we feel so confident about this filter, to be able to offer a 5-year warranty as long as these filters are being used. And we don't take away a warranty. We just extend it for 4 additional years is pretty much what we're doing. So these come in pads and blankets as well. Right now, I don't have a standard that's made as a bag or a cube, but it can be done if we needed to. So just keep that in mind. Now, when we talk about the models of this filter, we've sort of brought the models down into a little more manageable type, a little more of what we see as the higher usage type filters from our history with making filters, since the 50s. Is we've settled into 3. That just helps our distributors and our end users better select a filter without having to go through so much gyration in models. But like I say, they're all designed to work a little differently with different type of applications and coatings. So, just keep that in mind. If you did buy a Colmet spray booth within the last year, it would have shipped out with what we call our W5100 series, just as a standard, unless we were told differently. So that's sort of the middle of the run of the W series. I wanted to touch base again on our last presentation with the cost savings and the installation and the conversion. So there's a lot happening on this slide. I know I just took a slide from that presentation And we on our YouTube channel, and I just urge everybody to go to that because we've done a lot of work here recently with the webinars that we've been putting on that Judy mentioned will go onto our YouTube. But we've also created some bonus information that shot some actual live videos that kind of help maybe go in a little more in depth to some of the things that we discuss here in our webinars, because we're trying to get through our webinars in a quick manner for you. We're looking for 30, 40 minutes, so that we kind of have to abridge some of our information. But I urge you to go to that. We talk about installation of pad filters. We talk about the wire grids. A lot of people want to know. We talk about converting pad filters to blanket media and the amount of time it takes to replace those filters, to take them out and put them back in compared to each other. And if you missed the other webinars, you're talking about 60% labor time, and you save in labor time when you use blanket media over pad filtration. So if you didn't see those, I urge you to go and check those out. The whole webinar is there, as well as the additional videos. So let's talk about some new information. And why did I say, hey, let's talk about a manometer when we're talking about filters? So a visual gauge is required by OSHA. Now, it can be a manometer, which I'll show you right now. It can be a manometer. This is a gauge that a device that's sent out with all of the Comet spray booths. If it has an exhaust chamber, and it's for liquid painting, it has one of these. So it can be a manometer, a magna helix, excuse me. You can see photo helix sometimes, and things like that. It just needs to be some type of visual gauge that shows and helps to indicate the level of loading that the filter has. So with our type of filtration, and I talked about that depth loading, sometimes they look like they may be loaded. You look at the filter on the front, it has a lot of coating on it. There may be something dripping off of it, but that doesn't mean that filter down inside there has actually shut itself off yet. It may still have some life left to go. And the only way to really know that that's still available to you is to know how much pressure differential your booth can handle in your system. So being that we are a booth manufacturer as well as a filter manufacturer, we have a little different opinion on how manometers should be set up, I believe, than most people. You'll hear some people, talk about, just you go a half inch, and that's where you have to go. You'll hear some people say, well, you go 3/4 or 3/8 of an inch, and that's where you change it. Or, there's a lot of, you got to cover half of the filter face up with cardboard, and then wherever that is, that's where you have to change. So I'm going to talk through that a little bit with you, and why we might have a little different opinion on how to set that up. But so understand, your gauge is set up to kind of show a visual indicator. You have a little arrow as a baseline that shows where your booth operates with clean filters, everything balanced out, everything's good to go. No, nothing's been sprayed, right? That's your baseline. So you'll kind of see in our little image here, it's running at 0.05 inches. And then as your booth begins to load, you're going to see that pressure increase as the filters load, you're going to see that pressure increase. Now, the question is on this example, we put it just a little over 0.5. Well, is that the right place for your system? It may be, and it may not be. It may not even be close. So that's why it's kind of using just a standard rule of thumb to say this is how much deviation you get in a filter. It doesn't work. Different type of filter medias can run longer. With one coating type versus another coating type, it's possible for a filter life to be longer, than what it did in a previous one. So let's talk about setting up our manometer for our system, for the system that you have, the one that you're touching, the one that you use on a daily basis. So there's two ways to do this. To be honest with you, these are the two preferred ways that I give people. These are the ways that we use to determine where we want to start at, and then where we kind of define down to. So there's one way to do this, and it's to understand what your exhaust system's capability is. Okay, and you can do that in two ways. You can calculate the static pressure that's available to the fan, the filter load, right? So when your fan is designed, it's designed to operate at a certain CFM at a certain static pressure. And depending on how your system is running, you have a certain amount of available static pressure. And that, in essence, is how much you can load your filters. And then another way, which is probably the most precise but does take a little bit more time, which I think is definitely worth the effort, is you use the booth airflow to set the manometer. Okay, so let's talk through this first example of understanding our static pressure, the capabilities of our fan. It is a faster way to do it, and it does get you a really good baseline to where maybe you can start out that way and kind of see how things are operating. So I threw a little image here up of a general arrangement drawing from Comet. I assume if you have another manufacturer's booth, you're going to have some type of drawing like this that kind of gives an overall picture of what you're looking at purchasing or what you built. On there somewhere, I'm sure, and then our example is right here, is a general bill of materials. And it just kind of highlights the high level items. It's not breaking down the panels by panel and bolts by bolts, but it's telling you what you have. In this example, you have LED light fixtures, right? 24 of them. You have two 42-inch fans. This actual application used 3-stage filtration. So you had a blanket, and then you had panel filters and then pocket filters, right? So this is the example that we pulled out. But if you look at what we want to look at today is that line item that talks about the exhaust fan, right? And it tells us right here that we have a 42-inch tube axial, and it's rated for a certain CFM at a certain static pressure. And that's the thing that we really want to concentrate on for our purposes here today, is we're saying that this fan is designed to move 21,150 CFM, let's just say 21,000 CFM, at 1.25 inches of static pressure. Now, this system, because it used the 3-stage filtration, is already allowing for additional resistance, because now we have the initial resistance for 3 different layers of filters. So we need a little more static pressure. You can see from our drawing, our ductwork is pretty straightforward. It's going straight up to an ARV. We're not really seeing any additional static there. So whatever over our initial static of our filters is how much this particular application is going to be able to load the filter. Now, there is a maximum load for filters, and we'll talk about a little bit that here in a second, but it's honestly very hard to overcome that if you have enough area for running in your fan. Now, of course, if you get so loaded where you can't pull, you start actually dragging material through your filter. You just have to be cautious of that. Usually you won't see that until about 1 inch, 3/4 to 1 inch of resistance. You might see something like that, which in most applications, the fans aren't designed to handle that much static capability. So let's just kind of go through this a little bit, give you an example of what I'm talking about. So you take your initial filter resistance, which can be found in literature from the manufacturer. We can provide you testing data that can show you on our filters what the initial static pressure drop is. Well, the example that I put in here, if you'll notice that first line item of that little pop out is 0.03 inches of water column. Okay, so that's at 150 feet per minute, because all tests for the arrestants are done at 150 feet per minute. So first off, we'd have to understand what is the feet per minute that we're using in our application, to know exactly where we would be. There's a little chart indicated on the testing that shows as the velocity increases, so does the resistance. So we needed to be able to do those calculations, which is easy. Just filter face divided by the CFM is going to give you your velocity. So the second thing that we have to think about when we're talking about static pressure ability is we have to think about what is the fan seeing for inlet static. Is there ductwork on the inlet side of the fan? Are there elbows? Are there transitions? How is the fan being able to get air into the bottom of it? Because if there are transitions and there are elbows and there's 90-degree corners, then that creates static pressure. So we can measure that static pressure and be very technical and get in there and actually measure it with a pitot tube and find out exactly what that negative static pressure is so that we know the exact number. Or we can take some educated guesses, let's call it, and say, well, 45-degree elbow is going to bring me an 8 to 1/4, and that can help us set a baseline. The third thing is what is our discharge static pressure? Because now that the fan has static on both ends of it, so if there's elbows, is there long runs of ductwork, or the transitions, the ARV, which is your roof ventilator, on top, all generate some type of static pressure. Now, one thing that I wish I would have added in here is when we're thinking about, static pressure, we got to cover all aspects of that fan's performance. So let's say, and it happens sometimes, is there's an elbow that sits right on top of the fan. Okay, this is obviously not optimal for a fan at all. It probably cuts the fan down to about 40% of its ability, especially if it's on the intake, because now only half of the fan is loading because of the way the air streams around that elbow. But it does happen in the field. And what that's called is system effect. And what you have to understand is how much system effect you're adding into a fan. So I will tell you this, if you have a half-inch capacity fan and you put an elbow right on top of it, you have took all the capacity of that fan at that elbow. So any additional ductwork, any filter load, any of that is now starting to suffer your CFM. So to put a little math to that, just to simplify this a little bit, if our filter is at 0.05 inches initial static, okay, so let's say we're running around 200 to 220 feet per minute through our filter face, based on our testing data says that our initial static should be at 0.05. So that's what we're going to figure math-wise. We say, we had pretty straight ductwork, and we had an ARV up there, and maybe we had, a small offset. So we're just going to say we got a quarter of an inch of a discharge static. That gives us, if our fan was figured, so that gives us. I apologize. I've lost myself in my own math here. But what if we had a 0.05 and 0.25 discharge? That is a total static pressure of 0.3 inches. The available line there doesn't make a whole lot of sense. But what that's saying is that our ductwork and our filters have created 0.3 inches. So what was our fan designed for? Was it designed for a half inch of static pressure? Then that means we have 0.2 inches we can load, okay? But you say, Trey, that's not a lot. But when you think about it with our filtration, it starts out so low at 0.03, you do have quite a bit of loading there to run. If you start with one of our competitors' filters that I think of in my mind that starts out at 0.08, well, you know what? Yeah, now you've closed that gap. That filter is not going to be able to run as long. And the reason that I bring all this up to you is, and why I say that it won't run as long, and you may think in your mind, well, we run all the time. But what happens is when a fan exceeds its ability in static pressure, it starts to suffer its airflow volume. So if it was designed, in our example earlier, at 21,000 CFM at 1 1/4 inch static pressure, once that fan sees 1 1/4 inch static pressure, right, it's running 2,100. If it goes over 1 1/4 inch, our fan begins to produce less than 21,000 CFM, right? But the same is also true on the other end. If it's seeing less than 1 1/4 inch static pressure and we're running the fan at 100% speed, it's going to move more air than what it was designed for. So this is one of the reasons why someone that has a booth that doesn't have a variable controller on the exhaust and it just has a motor starter is not optimal by any means. If you have one of those booths and you want to save some money, then you put a VFD on it. Because what happens with that is I'm able to run my fan slower, which is less energy, because I don't need that much CFM because my fans haven't seen that resistance yet because the filters are clean. As the filters begin to load, the resistance starts to go up. The fan needs to be sped up at that time to make sure you keep the same amount of volume. Now, that can be done automatically and that can be done manually. That's however far you want to go. But another downfall to a system that runs just with a motor starter is that you move way more velocity through your booth than you need to, as well as through your filter face, right? So the slower your air velocity through your filter face, the more time and the more ability the filter has to perform. I have a little more time to catch that particulate on an outer sheet of paper before it bounces its way into the polyester in the back. I had a possibility of catching that earlier, right, where our filter is more open. But because of the higher velocity, we weren't able to turn that particulate, or weren't able to intercept that particulate because of the velocity itself, and therefore it penetrated itself down into the filter, right? So all those things are disadvantages to you. I know I didn't put any of that in the slide, but as I'm sitting here thinking about it, those are real world things that happen all the time that make manometer readings as well hard to justify and understand, because when the fan moves more velocity, it creates more resistance. But as the filters begin to load, the manometer doesn't really change, because now the fan is starting to slow its volume down. Even though it's running at the same speed, it just doesn't move as much air because of the resistance. So you'll notice, I mean, you might be saying, yeah, manometers are no good for me because when I turn them on, they run up to like an inch and they stay there and they never move from there and they go down. Well, they may, and that's because your fan is moving way more air than it needs to, and it's creating a bunch of static resistance either through the filter and through the ductwork, however the manometer is set up to see, and that's why that's happening to you. So anyway, so let's get to a little more precise way to do that. And to kind of talk about this, let's talk about a little background. So OSHA and NFPA require that a spray booth move a certain amount of airflow. Okay, everybody's probably heard that in a cross draft you have to move 100 feet per minute. If you're spraying electrostatic, you can get by with 60, right? OSHA also gives us a table in 1994 G10 that says that in all these different setups, you can run 50 to 250 feet per minute, right? So OSHA kind of defines this out. Then they go back in the 94 C62 and they kind of reference NFPA, which it just says that, hey, let's just not ever exceed 25% of the lower explosive limit of the solvent or the coating that's being sprayed, which is what the NFPA Chapter 7 says, is do not exceed more than 25% the lower flammable limit. The NFPA doesn't necessarily make any recommendations on velocity through the booth. It just says do not ever exceed the 25% lower flammable limit. So what that means is when Comet designs a spray booth, let's say we have a little small open front spray booth, and we design that at 100 feet per minute, or 125 if it's a standard, because we allow you to be able to make 25% openings in the side for conveyor if you wanted. But let's say we didn't need that, and we had 100 feet per minute. As soon as our filters load to the point that our fan can no longer take the static resistance, we're no longer moving 100 feet per minute. So now we're in a violation. Now, this probably happens every day in places around the country to where their booths are not actually moving 100 feet per minute. Now, a lot of people don't notice it until the overspray gets so bad that it's sticking to the walls and it's dry falling on their coated part, or it's migrating outside of the booth. If it's a pressurized booth, right, then it's blowing out all the doors and anywhere it can. And that's when a lot of times this comes about. But if you were ever in a situation where the authority having the jurisdiction come out there to measure something and it wasn't right, you're potentially going to see some issues there. So when we work through airflow through a booth, I did a video on this, and I put that image down at the bottom just to remind everybody that it is on YouTube. I go through it a little more in depth than what we will now. I walk through the math with you and kind of work through this. But to set up a manometer with the airflow of the booth, which is something I recommend anyway, and that way you know if your booth is performing the way it should, even aside from the manometer. But you set your booth up with clean filters and you balance that booth out. So if it's a pressurized booth, what pressure do you want to run at? Do you want to run at 0 inches, which just means that you're bringing in as much air as you're taking out? Or do you want to run slightly negative, which means that you're going to be exhausting more air than you're bringing in, which means you're pulling air through doors or, anywhere you can. You're testing all the seals of your booth at that point. Or slightly positive. So if someone opens the door, you would rather air blow out than suck in Bondo or, whatever might be outside of the booth, right? So it depends on what you're looking to do. But you need to set that up. It needs to be running that way. Then you need to measure the airflow. So I recommend using some type of anemometer, which are easy to use. The main thing is to make sure that the one you choose is sufficient for the range that we're talking about. It needs to be able to get down to probably 100 feet per minute. and tap out somewhere around 600 or 700. If you find a gauge that's good for 2,000 to 10,000 CFM, it won't read these numbers right. Gauges are set up to run most optimal in the center of their range. So if it's 100 to 1,000 CFM, somewhere around 500-600 is going to be your optimal range, right? So just keep that in mind when you're picking these instruments out. But what you want to do is you want to take that manometer, you want to take a reading of the feet per minute through the filter face. This is my preferred method to get airflow readings in a booth, because now you're not worrying about turbulence inside the booth. You're not worrying, is there a part inside the booth or not? We know that we're moving air through the filter face, so this is where we take the measurement. So you have to create a grid across that filter face and get as many readings as you can. I recommend 9 readings in each location and a minimum of 9 locations. Now, in my video, you'll see that we're talking about a chamber that only had 4 filters in it. So we actually decided, hey, 6 readings per filter was enough readings for us, right? So the more inputs you have, the more accurate your calculation is going to come out. So to calculate that airflow, you just take the sum of all of those readings you took and you average those by however many readings it was, right? And then you multiply that by your filter area, and that's going to give you your CFM. And what you're hoping to see is if your booth says, hey, we're moving 10,000 CFM, and we did our calculation, we see that, hey, we're moving 10 or 11,000 CFM, then you know that your booth is performing as it should at that pressure, right? And that's our base point for our manometer. So when we say, hey, this is our green arrow, we saw that earlier on the manometer, that wherever that pressure is across that filter face for there, that is our green arrow. Then what we have to do to be able to tell when we need to change these out. Now, again, we can use our additional static pressure to give us an idea of kind of where that's going to be, so we kind of know when we need to start doing these secondary readings. But most operators that work, or most painters that work inside of a spray booth, they can kind of tell you when the airflow is beginning to suffer. That means that the filter should have been changed before that point. But what we want to do to set that change out frequency to get the most out of our system, out of our filters, the most out of our total system, is we need to repeat that airflow measurement again with the filters loaded until we cannot achieve that 100 feet per minute. Now, guys, that might mean you're changing filters out a lot faster than you thought you needed to. But now you're complying, your booth is performing better, and if OSHA walks in there and does an airflow reading, you're not going to get in trouble, right? Now, you might see, man, I'm running twice as long as I was before. We thought our filters were loaded out just because they look so bad. And to be honest with you, we're able to run longer. So that's why this is important. That's why taking the time to do this can really create an ability for you to save some money on filters, because you can get some more longevity out of those types of filters. Also, if your filter's loading up too quickly, there's other models that we can use that'll possibly get you a longer life and keep that initial resistance down and try to take advantage of what we have, right? So I hope some of that made sense to you. I kind of feel like I wandered a little bit there, and I apologize for that. But again, I want to talk about the YouTube channel, because we have a lot of videos that we put on there recently. I mean, I just urge you to check them out. You can go back, fast forward, and, rewind and do all you want to do, for that. So I definitely want to talk, send you in that direction. To recap on our incentives again. So right now, if you register a booth for the W Series, if this is a new order or it hasn't shipped yet, we're going to give you an additional set of filters, just as a, hey, thanks for registering for the warranty. We are currently offering the free filter lock system and tool, and that's included in all new booths. And also, I'll send you the filter lock system free if you convert from a competitor's filter to our filter. Then I'll send that filter lock system out for free as well. Another part of that extended payment term is that anytime you replace those competitive filters, that we're going to give you that filter lock. And then also we're going to extend terms through our distribution network, ultimately to the end user, for 120-day terms. So during times like we're in right now, manufacturing's been cut back. People are thinking about, what does it take to run my business? And this is a way that we're hoping, hey, we know you have to paint, we know you need to buy filters, but what we're saying is we're going to give you several months to be able to breathe and not worry about, buying filters and filter costs for your production for at least 120 days. So that's all that I had. And Judy, we'll open it up to questions.
All right, Trey, thank you very much. Just a reminder before anyone logs off, don't forget to download your handout. And then I will go ahead and get to some questions now, Trey. First question is it came up early in the presentation, Trey. It's what about the final disposal of the filter as a residue?
Okay, so final disposal of filters is going to really depend on what kind of coating and what requirements are around that coating. If it's a landfillable, then you're able to dispose of in a normal, trash disposal. If it has some type of hazardous, portion to it or something like that, then it would be hazardous waste. Also, it's recommended that you take those filters and you soak them in water before they're ever disposed of. That way you keep any spontaneous combustions possibilities out of the mix there, because some coatings, have that characteristic.
Well, thank you, Trey. Another question is what is the required air velocity or airflow in a booth with manual sprayers?
Yeah, so like I say, normally that's 100 feet per minute if you're looking at a cross draft. In the OSHA chart, it goes and it defines that down to, I think, somewhere if you can run 75, something like that. And all of it depends on the application equipment. Comet designs boosts at 100 feet per minute in cross drafts and 50 feet per minute in downdraft orientation. So that's honestly how a lot of booth manufacturers set booths up.
Oh, thank you. Another question here is what is the widest and longest size that the W series roll media comes in?
Okay, that's a good question. The widest material that we can manufacture with a trimmed edge is 45 inches. I can get wider, like up to 47 inches, but on the edges, our layering might be a little different, and that's just because of the width of our machines that we have. So we trim at 45 inches. Our standard W series that we have as standard part numbers only go up to 30 feet, but we are able to make filters up to 90 feet long.
Okay, thank you, Trey. Along that line on the W series, another question here is what exactly does the 5-year warranty cover?
So the 5-year warranty is in essence an extension of the 12-month warranty that Comet offers for all of its booths, with the exception of the air makeup unit. So it's a parts-only warranty, and anything in the booth, AMU, the fans, the motors, bearings, right, flame control systems, valve trains, the burner itself, things like that are all covered under the warranty. Light fixtures are all covered under that warranty. Now, like I tell people, if you're 3 years into this and you've been buying filters from us and you're registered in this program and you need a new door latch, then I'm going to send you a new door latch. I'm not going to argue that that's a wear part. If you need some more door gasket, I'm going to send you some door gasket. You're looking for a hinge for some reason, then we're going to be very workable through that, because we've generated a partnership together, and honestly, that's how Comet has worked for years and years and years. So we're not really doing anything new there, but it covers pretty much anything functional with the booth.
All righty, thank you. I think that's all the questions we have right now, Trey. So if you wouldn't mind, just before we log off, everybody logs off, can we just go through a few slides here to close out the webinar? Appreciate if you fast forward. This is just the who to call list. As I mentioned, if you download this handout before you leave the presentation, you'll have this list of individuals. This is our Comet direct sales team, and all you need to do is contact them. On the right is the map showing their location, and on the left is all their contact information. Next slide, Trey. And as we mentioned in a few other presentations, the Comet website is a great tool. You can get all the literature there. It's broken down into different areas by different product groupings. All of our literature, as well as our manuals and instruction manuals, are kept there. Trey, there you go. And Trey had mentioned some other information. On the right of this slide here, you'll notice that's our new filter lock literature. And then, of course, here, this is a lot of the charts that Trey had referenced are in this in the W series and the Arrestor catalogs, just so you can kind of get a feel for the charts and what's best, which filter is best for your application. And then our next slide, please. This is the last, as I mentioned earlier, batch oven optimization is our last webinar that we have coming up. So if you haven't signed up, that's on Thursday, please sign up. One more slide, Trey. And then Trey had talked a lot. We have put numerous different videos on the Comet channel. The manometer video, that's up there ready. The airflow calculation chart, that'll be there by tomorrow morning, or actually later today, as well as this presentation itself. So we have a lot of good content there, because we know a lot of people, they change in a facility, a paint facility. It's a good tool to go to have people reference and gather a lot of additional information for their facility. And then I think there's one more slide, Trey, and that's it. So I don't see any more questions have come in. So we just want to thank everyone for attending today. We really do appreciate your attendance at these various different webinars. And that will conclude our webinar.
Thanks, everybody.
And Trey, we may have, let me see, I think a question. Oh, someone had asked about a future webinar about the auto seal door. That's something we can add to the oven presentation. So I think that's it. Thank you very much.